Welcome back to TrueNAS Tech Talk. Today, we'll be digging into some of the tiering that already exists in ZFS, the ARC, the L2ARC, Special VDEVs, and SLOG. What are they for? How do they interact? And which ones should you use on your system? Kris also has a nice update about LXC containers in TrueNAS 26. Testers are welcome to play with our new Libvirt-powered nightly images. Stick around.
We're back this week. We had a lot of fun last week with the technical deep dive. Thank you, Kris. And we're back with more because apparently we didn't learn a lesson. We enjoy this kind of thing. And we're all nerds at the end of the day. Kris is going to be taking us through some good stuff about ARC, L2ARC, SLOG, Special, all the interactions between them, best practices. So this is going to be a good one if you really want to get into how to tune your TrueNAS properly. A little later, we're going to talk about LXC containers and give a little update on what's been going on there. We've been quiet on that one for a while. Got some good things to talk about. Looking forward to hearing this. So, Kris, let's dive right in. Enlighten us.
Absolutely. I love doing the technical stuff. I like that it was appreciated, and I got lots of good comments and discussion and feedback kicked out of that. But I did get some questions talking about, how these different components of the, sort of tiering that already exists in ZFS, how does it work? And, maybe we can correct some of the misunderstandings and double down on some of these things about how we can tweak and tune what we've got. So one of the big things, of course, that really distinguishes ZFS from pretty much everything else is that adaptive replacement cache, the ARC. That's your first level of performance enhancement in ZFS. And that's part of why people say, hey, ZFS needs so much RAM. The first part to understand, and I see it all the time, is people say, hey, why is ZFS eating all my RAM? Because free memory is wasted memory.
Mm-hmm.
If it's sitting there empty, it's got nothing in it, why is it in your computer? And especially nowadays with the cost of RAM, you want to use every bit that you've got. So the idea is, ARC is going to fill it up as much as it can with what what ZFS knows or thinks is going to be your most frequently and most recently accessed data. It's going to put it together. It's going to compress it already. All of the ARC stuff is compressed. So you're getting even more space efficiency than you could before. If you have, 32 gigs of RAM in your system, but your data is compressing at a 2-to-1 ratio, you're effectively getting 64 gigs worth of cache data. It's pretty valuable in that front, just to begin with. So
we should clarify, though, Kris, it's not that ZFS needs it all and will hold on to that forever. It will try and be a good neighbor and allow other processes to also consume RAM and shrink. So again, wasted RAM is the key phrase here. It doesn't want to waste memory, but it will play nice and give it up if other folks say, yeah, I need some extra memory to go do processing.
Absolutely. That's one of the important things about ARC is that the data there is all, it's that fungible, it's discardable.
Mm-hmm.
ARC is in RAM, so when you lose power or something, obviously your RAM empties out. So you never want ARC to be the only location that your data is in. Your incoming writes do temporarily land in ARC. If they're asynchronous or synchronous, they will both land in ARC. The only difference is your synchronous writes get carbon copied to your SLOG device, which is, again, it's a log, it's not a cache, but we'll go into that one later. So the idea behind the ARC, what makes it different is that it's combining both a most frequently used, and a most recently used algorithm. It starts out when you open up ZFS, when your module's loaded for the first time, at a nice even 50-50 ratio. So how does it change that over time? How does it tune it? When you read something the first time, or you write it in the first time, it's going to go into the most recently used. It's going to land there and say, okay, I have a value of 1. I'm on the MRU list. If you read it again, then you increment the count. You say, hey, I read this again. Move this over to the MFU, most frequently used. And then it will start to build up that side. Once you hit that, both sides of your cache, you're now completely full. It's then going to have to say, okay, if something new comes in, whether it's from a new write from the network or a new read from the disk that wasn't cached, it's going to basically pick something off the bottom of the lists and discard them.
Mm-hmm.
Those discarded entries, not the data itself, but just sort of the header and the index to, hey, here's where I was pointing, here's where I was caching, that is stored separately in what's called a ghost list. And there is a ghost list for each side. So as those ghost lists begin to grow, if you get a read that ZFS says, hey, this was in the ghost list on the most frequently used side, it's going to bring that back in, and it's actually going to increase the MFU side at the expense of the MRU side. So it's going to say your frequency reads are more important than your recency reads. And it's just going to change that balance just a little bit at a time. The more hits you get on the ghost list, the more it starts to change that ratio until eventually your system reaches sort of that balance point between what your actual data access patterns do. So, everybody's access pattern is going to vary. Some people are doing a lot of, very recent data. They'll write something in, they'll read it back, and then they'll kind of go on to the next chunk. They'll bring something else in, they'll read it in, and then they'll move along. That's where you get a lot of churn in your ARC, in your MRU, if it's just flushing that through over and over. You really want to have it caching your frequently used things. So over time, most systems will start to bias away from that 50-50. Maybe that's something down the road that we could look at changing out of the box to say, hey, let's start it with a bigger bias for that frequency so we don't have as long of a warm-up time. So let's talk a little bit about, tuning ARC. One of the ways you can do it, there's a really handy script in TrueNAS called ARC Summary. You can look at this, and this is going to give you all those big, gory details about your MFU, your MRU, your ghost hit lists on both sides, as well as starting to break it down further into demand and prefetch for both data and metadata. So a demand is ZFS actually saying, hey, I need this data, I'm demanding it, and I want it right now. That's the most obvious one. Something from outside ZFS said, I need to read this data. The prefetch lists are, of course, where it's doing its predictive prefetching. It says, hey, you read blocks 1, 2, 3, and 4. The prefetcher is going to say, you're probably going to take 5, 6, 7, and 8 next. So the prefetch stats get recorded to say, hey, how successful is prefetch being? So you'll be able to see if you have a sequential access pattern for your data, you should be able to see that prefetch is getting lots of good hits.
Yeah.
Just like with the ghost lists, as you get more hits on your prefetch, it starts to say, I'm going to grab bigger chunks at a time. So it is doing this sort of adaptive behavior. And hey, that's the A in ARC is adaptive, Kris.
I remember a few years ago, we had to make a tweak to the prefetcher because we had some reads coming in out of sequence. So we would see a request for 1, 3, 4, 2, or something like that. And the prefetcher wasn't smart enough to say, oh, well, they also want 4, 5, 6, whatever the next in the sequence was. So we had to store that, reassemble it, and say, oh, this does look sequential now. Gosh, this would be now several years back, though. But those are the kind of things you do in the background to handle messy data access from clients.
Absolutely. And one of the things in conjunction with that, I think it was a bit more recent, maybe 2 or 3 years ago, was we added multiple streams of prefetch. So it's now able to understand if you have 4 systems that are reading simultaneous streams of different files. So instead of seeing the reads going to, 11, 21, 31, 41, 12, 22, 32, 42, it was able to realize, hey, these are 4 different read streams going on. I think it's 16 parallel read streams that we can pre-cache now. I'd have to check in on that one, but I definitely know it's more than one. So that when you have multiple client systems accessing it, you're not subject to that wonderful I/O blender effect.
An important point I want to make here too, Kris, because we're talking an awful lot about memory and reads and writes into RAM. And this is something that people maybe overlook during their builds. I know a lot of people build their first TrueNAS out of what's available on hand, but eventually you say, I want to do something really cool and high end and need performance. RAM speed matters a heck of a lot for this. You're doing a lot of mem copies all around with a bunch of write and read operations here. So the faster RAM, the better, which, sorry, everyone, I know it's expensive right now, but that still matters a lot in planning your performance build.
Absolutely. If you're gunning for the high end of performance, it matters a lot more. When you're looking at 40 and 100 gigabit or beyond that, you really want to be up in that high speed DDR4 and DDR5 kind of territory. For those of you who are just using, 1 gig Ethernet at home, hey, you're fine with DDR3. And hey, I mean, I'm saying, you're probably good up to 10 gig, even with if you have, a quad channel DDR3 system, you're probably going to be fine. You're going to be able to sustain that quite easily off some DDR3. So you don't necessarily need to go there for everywhere, but believe it or not, RAM speed can start to become a performance bottleneck as you get higher up. So additional ARC tuning things is that the idea, of course, ARC being the C is, caching. If you have a client system that has its own cache that might have better insight into what you're putting there. So if you have a virtual machine running on top of this, that does its own page caching, or you have a database system that uses its own memory on the database machine, if it's physical hardware, if it's a VM somewhere else. If it's holding the cache, this is one of those scenarios where you may want to flip the switches for your data set or your ZVol. There's a property called primary cache for your ZFS datasets in ZVol. It can be set to all, metadata, or none. Now, you basically never want to use none. That's almost just there for a troubleshooting question.
Mm-hmm.
But if you have a client that does its own caching, this might be a scenario where you could turn your primary cache for that data set specifically to say, I only want to cache the metadata from a ZFS perspective. Maybe my database has better insight into this. Maybe it's going to be able to handle its, row sorting or row understanding a little bit better on that client side. Or maybe you just have, you don't want to waste memory, because if you cache it on ZFS and you cache it on the client, well, you're wasting some RAM. You might not. Yeah, you're going to waste your memory copies. You might be accidentally polluting that MFU and the MRU table with stuff that doesn't need to be held there. This is a case where it's not free memory, but it's still wasted memory. You might want to do that, but remember that ZFS ARC is compressed. So if you get a net better gain by saying, hey, do my caching on ZFS because my data compresses really well and I get twice as much here, that might be better. So again, everybody's mileage is going to vary. What you have to do with these things, you have to tweak them a little bit. You have to tune. You have to collect your before and after metrics and figure out, hey, is this going to be the right change for me? For the most part, the defaults set by ZFS are usually correct. Use them as your starting point. Benchmark what you've got. Make sure you have a good baseline before you start tweaking and tuning. Don't just go out and grab something that you saw, hey, I should set this because I saw it on a Reddit post, a YouTube video, or maybe even a TrueNAS forum comment that might be outdated at this point. Mm-hmm. Lots of things have changed in ZFS over the time.
Yeah, or specific to that person's hardware, their use case. Again, not all use cases are equal. Take it with a grain of salt. But moving up the stack now, let's get into L2. So we have another ARC. What's that all about, Kris?
Yeah, that's your level 2 adaptive replacement cache. Mm-hmm. And this one's a bit of a misnomer because it's not really as adaptive as your primary ARC. Lots of people look at this and say, hey, this is just an extension of ARC. I can strap on a cheap SSD onto my system, get a whole bunch more equivalent to RAM. Well, it's not the same. L2ARC it fills by taking what could have been evicted from the tail end of ARC, both the MFU and the MRU queues. It's basically going to say, hey, predictively, the last certain amount of the tail of my ARC is going to be considered for inclusion into L2ARC. It then gets pulled into there by a periodic process that's scanning that tail and writes it to the SSD. The L2ARC itself is what's called a ring buffer. It's first in, first out. So basically, think of it as a moving pointer going all the way along the length of that SSD. When you write something in, it's just going to move it along and it's going to keep going around the end. Once you continue to write over there, it's just going to overwrite the first data that it sees. It's not overwriting the least used, the most, the least frequently or the least recently used. It's just going to overwrite the first thing that's in that space. The way that things get saved from that is when you get a read from your L2ARC, well, it gets promoted back into primary. It's kind of like the same as the ghost hits. It says, hey, this came off the L2ARC. Where did it come from? It came off the MFU side of L2ARC. Maybe we need to grow that a little bit more and avoid things going down to the SSD. Because SSDs are fast. They're not as fast as RAM.
Mm-hmm.
Yeah.
And endurance concerns as well.
That's one of the reasons that the fill rate by default out of the box on ZFS for L2ARC is considered, a lot of people say, hey, it's so low. I think is it still like 8 megabytes per second fill rate on an SSD, which is, extremely slow these days for SSDs. Most SSDs nowadays are starting to measure themselves in gigabytes per second of writes. But the challenge is if you're telling it to fill your L2ARC at a rate of gigabytes per second or even a high number of megabytes per second, well, L2ARC is continuously trying to fill itself. You're just going to be subjecting that SSD, assuming that you're going through and doing reads from ARC all the time, to an equal amount of write pressure as you're doing for your reads. You're eventually going to burn out that SSD. That's kind of, tying back to that care and feeding of SSDs previously. Writes are what burn out solid state drives far, far faster than any sort of adjacent read, disturb, or anything. So even at the stock rates, a consumer level device can fail within a couple of years. Thankfully, L2ARC is, completely disposable. You lose an L2ARC device, the only consequence to your pool is a loss in performance. So that's one of the things that people say, hey, I can put an L2ARC on there. It's one of the things that it's a low risk addition to your pool. You can put it on there, see if you actually benefit. Again, check that ARC summary metric report, see if your L2ARC is getting a good amount of hits. Usually, I think it's 25% we expect to see from an L2ARC. It's a little bit more speculative. It's not quite as good at ARC as doing its job. If you got 25% hit rates on your L2ARC, it's probably worth keeping. If you got below that, maybe not so much.
What about metadata, Kris? Because special VDEV class metadata, that's got a lot of mystery surrounding it. And frankly, I don't blame people for being a bit confused because it's now starting to grow and do a lot of different things too. So that'll need a whole different explainer at some point too. But give us a little background on that.
And it's going to continue to evolve and do even crazier things in OpenZFS 2.4, coming with TrueNAS 26 later on this year. The big question about the metadata and the special VDEVs are people saying, well, if metadata is already living in my ARC and it can potentially be pushed down to my L2ARC, why do I need a metadata SSD? The big challenge for it is, of course, your ARC and your L2ARC are both on the read side of things. If you're doing a lot of writes for metadata, those tiny little writes, that's what your special VDEV is for. It guarantees a higher floor on performance for your writes because you're getting those small writes off of your spinning disks, which can help you mitigate but not entirely avoid fragmentation on them. But it also means that you have a higher floor on performance for cache misses. If somehow your metadata isn't in your ARC, it's not in your L2ARC, or it's the first time you've rebooted your system after an update, or in the case of an HA system, a pool import after a failover. You say, hey, all of my metadata, I don't have to go down to a spinning disk or, a slower QLC SSD. I can put them on some really fast ones where I'm guaranteeing that all of my metadata reads come through quickly. So that's for my directory listings, indexing things, looking them up. That comes really quickly. It's an enhancement over and above, a large ARC and a large L2ARC for those workflows, certainly. It is important to know that you have to make sure you do make it redundant. And I can't blame people for being a little bit wary of metadata with how often I've said that before. You have to make sure it's redundant. If you just have one SSD, you can put it in fairly safely as an L2ARC, observe whether or not it helps you. And if it doesn't, get rid of it.
Yeah. Now you got to commit if you're going all the way with special VDEVs.
Exactly. Even more so in the future when we start giving you the ability to have entire data sets live primarily on there and then make them start to act as the SLOG devices as well. If you get some nice metadata SSDs and you don't want to have a separate log device.
Well, we talked about that in our tiering discussion a few weeks back as well. Is like that's the first foray into finally having a true flash spinning tier in one pool, which is interesting. Exactly. So again, a whole other episode on that down the road.
Absolutely. But speaking of log devices, we did dig into those quite a bit in the last one in the care of feeding, but we're going to poke into them just one more time. Again, a log is still not a cache. It's not the only place where your data resides except during those pool restores and recovers. Under a normal circumstance, you're never reading from the log device because it's just a new physical location for that ZFS intent log or ZIL. So when you write something into ZFS, it lands in ARC, certainly, but then in a sync write scenario, it's also being, kind of carbon copied to that log device. That does mean that your log device is the speed limiter for your sync writes. But even in a scenario where you write that data and then immediately read it back, that read would never come from your log device. It's going to come from ARC. Even if you say, hey, the transaction's done, we've flushed it out of primary memory, it's being, purged into the log. It's never going to be read from there. The only time you're reading from that is if you have a write, the transaction group didn't close, and then your system crashes, you have a kernel panic, something like that, and it has to recover and replay that log into its proper place in the pool. So again, log devices, useful if you have sync rights. They're not going to speed you up if you don't.
Are there situations where you'd want to avoid putting a slog in, Kris? I know we've been asked this before about, I have a ton of VDEVs and I'm getting good performance. Just sometimes it hurts you putting a flash single slog in.
It can hurt you in that scenario. If you have all flash VDEVs on the back end, the combined speed of your VDEVs can actually be faster, especially for certain workloads, than a single log device. If I have, a 24 bay SSD system, it's all NVMe, and I'm writing sync writes to it, I can probably get a lot more throughput in, a large record size. If I'm writing, if I'm doing video editing directly off this and I'm writing to there, it's probably faster for me to just dump all of those blocks right to my whole 24 wide bay of SSDs than it would be to say, oh, I'm going to stick one Optane device in there.
I'm bottlenecked on the one device now.
You're bottlenecked on one device. You have a single queue depth you got to sit behind. You have a single, NAND device that's in there. And then, you don't have all of that parallelism from being able to say, I'm going to write to, 8 3-wide RAID Z1s at the same time. So that would be a scenario where a slog could slow you down. But just like an L2ARC, you can remove a slog after you add it. Again, take your benchmarks at the baseline, look at the defaults, record it. The data that you collect makes the difference between, was this a good change or was this a bad change? Knowing is half the battle, and the other half is repeated testing.
That's good. Thank you, Kris. Appreciate the deep dive on that. Again, looking forward to seeing questions from folks, because people always manage to find other more interesting edge cases they want to know about. Let's move into our next topic, though. So we wanted to talk a little bit about LXC and give you an update on what's going on there. So, folks, we had talked about this. Gosh, this probably would have been the fall of this last year. Last time we maybe touched this topic. In Goldeye, we still had some of the experimental container support, which is the Linux version of jails for the people coming from the core side who are familiar with that. We wanted to announce that in the nightlies, the migration from the Incus backend is complete. Everything's fully been moved over to the Libvirt backend. So what does that mean? Well, it means a few things. We dropped the experimental label from the UI. So if you're running the nightlies, you'll notice that's gone. It looks like it's a fully baked feature now, because it is. We're looking for feedback now from users who are testing the nightly. So please give it a shot. Let us know if anything doesn't work. But before you do that, you maybe want to know what changed. Well, from a feature standpoint, actually not that much. That's kind of intentional. The UI will look a little different. It'll look a little bit more akin now to the VMs and the apps. Containers and VMs and broken out into their own section again. Deploying a container is going to give you all the nice LXC catalog of images you want to deploy. We retained all that functionality, so you have your beautiful list of all the different Linux distros and pick and choose the one you want. You'll have all the same basic and advanced options, same support for things like restricting container to specific CPUs, setting different advanced init options for the particular distro you want to run, changing some of the capabilities options between the default, allow, deny. And then, of course, you'll still have options for doing things like GPU pass-through if you have one installed and have the driver support. Note, it's not quite the same type of pass-through as VMs. You're not passing through the whole physical device. This is more of a shared situation, just like you get with apps. And then on the NIC side, again, it's pretty standard. You'll have support for VirtIO as well as the standard emulated Intel E1000. So again, all pretty much what you'd expect to see. And then lastly, USB devices can also still be selected and exposed to the container as well. I've been playing with it here for a little bit, Kris. It's boring in the best way possible because I haven't hit any bugs yet. It just kind of works. So that's great. But that's why we want other people to give it a try. And again, kick the tires a little harder. Let us know if you can see anything shake out. Once this gets out into people's hands for TrueNAS 26, of course, we're going to have the basis now for all three kind of third-party service use cases with apps such as Docker containers, now full-fledged, more like jails with regular containers, and then, of course, VMs. And we'll be looking at those three and seeing which ones need to evolve a little further in subsequent updates to TrueNAS.
That sounds like a really good opportunity. And for those of you who have been looking at this, I know there's been a lot of threads in the forum asking specifically about that USB pass-through. So if you're one of those folks who has, an unsupported USB device for TrueNAS, it's a USB TV tuner, one of Google's Coral TPUs where I think they deprecated the driver out of that one.
I think that's
USBs
gone now,
even.
yeah.
But, if you've got one of those and you have an extra system, hey, throw a test copy of the TrueNAS 26 nightlies on there, pass that through, see if that's working for us, because that's one of those things. Now that we're getting this, the GPU sharing, somebody try this out between, an LXC and a Docker app at the same time. Make sure they can share their GPUs, lean on that stuff and break it a little bit for us, because we're still in the early stages here. We want you to break it when it's in the nightlies, or maybe the betas. We don't want to just wait and find this out on release date.
Earlier is always better.
Exactly. We've got a pretty wide array of devices here, but we don't have everything. So if anybody's out there, you've got some of the stuff that we wouldn't lean on for like an enterprise storage or even one of our home cases. I don't have a TV tuner over USB. If somebody does, please plug it in, try and break stuff, test your weird unsupported, USB hot plate or something to keep your coffee warm.
I have some little USB device that controls some of the lighting inside one of the chassis of my system. Okay, cool. I haven't passed it through to play with it yet, but it shows up in the list of here's something I could pass through.
RGB lighting, Zigbee controllers, do crazy things like that.
Yeah, have fun with it. Now, so before we get asked, because somebody is going to ask, Kris, what things should people pay attention to? So migration. People are going to say, well, I have some of my containers set up in Goldeye already. They're using Incus. How is that going to work? So good news is the containers will be migrated and preserved. So when you go from Goldeye to the nightly, you'll go fire up the containers UI. You'll see your containers. We haven't changed any of the actual data. That's still your Debian or whatever, Rocky Linux or whatever variant you run there will still show up. In most cases, it will just work. Worst case is if you're doing some kind of exotic setup or you were doing any custom GPU USB pass-throughs, you might have to go and reconnect those devices again and say, yes, I want to reconfirm I'm passing through that GPU. But everything else should just kind of go and work out of box. But again, that's where we want to make sure it's all good before we get to release. So try it out. Let us know if you do see any issues on the migration side.
Yeah. If you want to be extra safe, disable your container auto start for stuff like that before you do the upgrade. Say, hey, this guy had a custom USB pass-through setup for it. I'm going to disable auto start, do my upgrade, go in there and just look, hey, does it look like it's got proper enumeration on my USB? Is this thing still pinned through? If it's not, then you fix that and you fire it up. Do your snapshots beforehand. Just do that backup, like I said, and give us the data. We want to hear it, and we want to hear it early.
Excellent. Well, thank you, Kris. We've had a pretty good session today. A lot of good stuff. I don't think we'll get into all the questions and answers. We've been getting some good ones from you in the audience, so maybe we'll queue those up and do a big Q&A episode coming up soon. One thing I do want to mention real quick, because we've had a question from a couple places about web sharing and custom host names and certificates. And I don't think I've mentioned this or really gone into that on previous episodes, but I do want to confirm, once you have web sharing enabled, of course, you can use your own certificates and host names, all that good stuff. So if you've manually created any certificates, you have your own host names defined, those will be picked up and exposed, and WebShare will honor those as well. So you can use the TrueNAS Connect provided host names or, again, your own custom things. So both use cases will be valid and supported.
Yeah, it's not specifically tied to having to use that TNC name. If you got your own local name on your domain, you just want to punch in, truenas.my.home or whatever, hey, that'll work just fine. And you'll still have your SSL certificate signed and working properly.
Yep. So again, try it out. That's all available in the nightlies as well. We would love to have feedback if people are already kicking the tires on it. Otherwise, a good episode today. This has been great. Thank you, Kris, for the deep dive. Really appreciate it.
Hey, I always appreciate doing those. By all means, if people have further technical questions or you want to see me just go, neck deep into some other aspect of ZFS or TrueNAS, please go ahead, post it down in the comments. Reach out to us at t3@truenas.com or on the forums at forums.truenas.com. Please, again, do the usual YouTube things for us. Give us those likes and subscribes. We really appreciate it. Continue to engage with us in the comment section and anywhere else you find us on social media. Thanks again for tuning in. Kris and I will see you next time.